Hi everyone, let's solve today's daily challenge, that is minimize deviation in array. So in this question we are given an array nums of n positive integers and we can perform two types of operations on any element of the array, any number of times. So if the element is even, you divide it by 2. If the element is odd, you multiply it by 2. So the deviation of the array is the maximum difference between any two elements in the array. So what you have to do, you have to return the minimum deviation that you can have after performing some number of operations. So let's understand what the question is. So here you are given this array. So there are two kinds of operations that you can do, right? So the first operation is that if you have an even number, right, you can divide it by 2. And if you have an odd number, you can multiply it by 2. So you can do this to any a particular number, any number of times, right? So right now, if you see the deviation of this array, so how can you first calculate the deviation of the array? So deviation is nothing but because you have to calculate the maximum difference. So the maximum difference you can only get by taking the maximum value of the array and the minimum value of the array and subtract them, right? So that is the maximum difference. So that is what deviation is. So right now, if you see the deviation, it is 19. So now let's try to do some number of operations and get a minimum value that we can get. So what can we do? So if you see, this is very large, but it is even. So what for even values, what we can do? We can divide them by 2. So if we divide this by 2, what we will get? We will get 10 here. Now if you see the deviation, the maximum value is 10 only and minimum value is 1. So the deviation will become 10 minus 1, that is 9. Now again you see, if we can decrease this maximum value, so decreasing the maximum value, you need to check if it is even or not. So it is even, so we can decrease it. So what we will get? We will get, so to decrease you will divide it by 2 because it is even. So you will get 5 here and 3 here. Now if you check the deviation, what is it? So if you see 5 and 1, it is 4. Now you see that the maximum value is odd. So can we reduce it further? No, because for odd numbers we can only multiply them by 2. So we cannot reduce it. So what we have to do? We have to do something to this minimum value so that we can increase it, so our deviation will be lesser. So if you see, this is an odd value. So for odd value we can multiply by them by 2 so that we can increase them. So we can multiply this by 2. What we will get? We will get 2, and here you will get this, and now your deviation becomes 5 minus 2, that is 3. Now let's see if we can do any number of operations or not. So you see, this is the minimum value and this is the maximum value. You cannot reduce it because this is odd. You can only increase odd values, and you cannot decrease 2 because we cannot increase 2. Why? Because this is even. So for even values we can only decrease them, right? So this is the only condition. We cannot change the minimum and maximum value. So that is our answer. That is the minimum answer that we have is 3 in this case. You can't do any other operation to get a minimum value than 3, right? So that is the result for this array. So now let's observe some things here. First thing that you observed here is for this even case, that, let me write it here. For even values can only be decreased because we are dividing them by 2, and the odd values can only be increased because we are multiplying them by 2. So this is the first thing, right? Now the third thing is, we need to get a minimum and a maximum value out of this for each and every iteration. So how can we do that? So for that we can have a max heap, right? That is the best way that we can get a minimum or maximum value, right? Because after performing some number of operations, our values are changing, right? So for that we need to maintain it. So we need to maintain the maximum value or a minimum value. To get that, we can only use max heap, because the other approach is to then sort it, right? Sort this array again and again and try to get a maximum value. So that is why we are using a max heap. So what is a max heap? It is just a binary tree in which the root is always greater than its children, right? And once you delete the root, it adjusts it in such a way that the root stays the maximum, right? So that is what max heap. And priority queue is also the same, just that it is a queue, but the top of that queue always has a priority, that is, it is always maximum, right? So what we will do, we will create a max heap here. Now you might say that similar thing we can do for the mini, but wait, we will see why we are not creating another heap, right? So we will create max heap. Then the fourth observation is, can we, try to reduce the number of operations, right? Can we eradicate one of the operations here, right? That is either this first operation or the second operation. So what we will do, we will eradicate the odd operation. So how can we eradicate the odd operation? That is by making all the odd values inside of the array even. So if you see, all the odd values are, so our array is 4, 1, 5, 20 and 3. So now our array will become what? So now our array will become 4, 2, and what are the other values? 4, 2, 10, 20 and 6. 4, 2, 10, 20 and 6. Now you may ask, why are we only eradicating odd and why not even? It is because for odd values, if you multiply any odd value by 2, it is guaranteed that that value will be even because you are multiplying it by 2. But for even values, if you divide them by 2, there is no guarantee that the number that you get is even or odd, right? You might be getting an even number. So that is not possible, right? That you eradicate the even operation, because still you can do even number of operations, right? Because for this only you can say that the array contains 20. If you divide 20 by 2, you will still be getting an even value. So an even operation is still valid, right? So that is why we can only do this for odd, because if you multiply any odd number by 2, it is guaranteed that you will get an even number, right? So that is why we are eradicating the odd operation. So let's write it here, eradicate the odd operation, right? Now let's see what we will do. So we will put these values inside of the priority queue, and we will also here maintain a mini variable which will contain the minimum out of these values, that is 2 in this case. Now what we will do, we will be traversing inside of this priority queue and we will be performing our operation, that is the even operation, dividing the number by 2. Now let's see how will we do that. So now what have our array has become this. Now let's traverse in this array, right? So we will be having a priority queue, right? So the priority queue will be containing values like this, right? So this is what our priority queue will be containing. This is the first iteration, right? Now what we will do, we will take the maximum value out of this priority queue and the minimum value we had already calculated. So what we will do, we will take a deviation variable and inside of it we will be calculating the deviation, that is maximum minus minimum. So what we will get, 18. Then what will you do, you will divide this value by 2 because it is even, right? And you will push it inside of the priority queue. So now your priority queue will become, also update the mini here by whatever the top value is divided by 2. So that is minimum of 2 and 10. So it will still be 2 in this case, right? Okay, wait. Now let's do the second iteration. In this first iteration, our priority queue would have been become 10, 10, 6, 4, 2. Because what we are doing, we are removing this top element and we are dividing this top element if it is even and again pushing it inside of the queue. So now we will again take the top. So our deviation will become what? It will be 10 minus the mini value, which is 2. So 10 minus 2 is 8, right? And we will again update our mini to 10 divided by 2, that is 5. So still it will be 2. Now the third iteration, let's see. For the third iteration, what will happen? We have 10 here, right? So right now, after this particular operation, what would have happened? We would have removed this and we would have divided this by 2 and put it inside of the queue. So we would have, now our queue will contain 6, 5, 4, 2. These are the values which our queue will contain. Again calculate the deviation. It will still stay the same, and mini will also still stay the same, that is 2. Let's perform the fourth iteration, right? So let's see what we will get. Now our priority queue will be looking something like this, right? Because take the top, divided by 2, push it inside of the queue. So we will get you will get 5. Now again calculate the deviation, that is 6 minus minimum value, that is 2. So you will get 4. Update the minimum value, that is 6 by 2, that is 3. So minimum of 2 and 3 is still 2. So minimum is still 2. Now we have to do a 5th iteration here. So what we will get here? Now our array, our priority queue will look like this. Okay. Now let's see. Now you see, first let's calculate the deviation. We will get 5 minus this minimum, that is 3. And then again, okay, don't update min. Now if you see that this 5 is an odd number, it is odd, and this is the maximum element, right? If the maximum element of the priority queue becomes odd, you cannot decrease it by performing any operation, right? Because odd numbers, as we saw, can only be increased by multiplying by 2. So you cannot decrease this odd number. So that means there are no other operations that you can now do, right, to get a minimum deviation. And there is no use of still iterating inside of this priority queue, because our maximum is 5, right? And it will stay 5 because we cannot change the value of 5 by any means because it is odd. So we will, at this point, we will break outside of priority queue and we will return deviation, right? So that is all the things that you have to do. So first thing we saw that even values can only be decreased and odd values can only be increased. Then what we said, we can create a max heap, right? You see here that we are calculating this min in every iteration. So that is why you don't need to declare a min heap here, right? So only max heap can work for us, because min we can calculate it in each and every iteration, right? So we are having this max heap, and what we will do, we will eradicate the odd operation because we can, right? So why not remove these operations, because we don't need a headache of a number of operations. So we have removed this operation. So now we only have one operation, that is take the even value and divide it by 2. So that is what we are doing. We are traversing inside of this priority queue, and we are taking the top. If it is even, just divide it by 2 and keep calculating the deviation until the top element becomes odd. So because when the top element is odd, you cannot do any number of operation as it is odd, right? And odd values will only be increased. So I hope now the process and the intuition of the question is clear. Now let's code it out, right? So first what we will do, we will create a priority queue, right? It will have integer as value and pq, right? Let's also declare our answer variable here, right? Answer will contain the deviation, right? So it will be initially int max, and with it also let's declare our min variable. Min will be also int of max, right? Now let's traverse. First let's create our priority queue, right? So what we have to do, we have to traverse in this vector, right? Dot size and I plus plus. Now what we have to do, we have to see if the value inside of it is odd, right? We have to eradicate the odd operations and as well as make our priority queue. So we will check if the number is odd, if nums of I modulo 2, right? If it is odd, then what we will do, nums of I will become nums of I into 2, right? And after that, do what? Put it inside of the priority queue, pq dot push nums of I, and also calculate the minimum value here, that is this, right? And nums of I. Now our priority queue is complete. Now what we will do, we will traverse inside of this priority queue. While let's traverse like this, because the condition at which we have to jump out of the loop is when the top element becomes odd, right? Not when the priority queue is empty, right? So let's now perform the operation. So first, what did we say? We said that calculate this deviation value, that is answer minimum of this answer value and the maximum value. So let's take the maximum value inside of this current variable. So we will say take the top out of this priority queue and remove this top and do operations with this top element, that is calculate the minimum value of this answer, right? That is the deviation. So how will you calculate? That is maximum minus minimum. So maximum is what? That is inside of this current, and minimum value is min I. So after we have calculated this, we have to check, right? If this element, if this top element, if this has become odd, so at that point, as we said, we have to jump out of the loop. So what we will say, we will calculate current element. We will check if it is odd. We will say break out of this loop. We don't need to do any more iterations. Otherwise, you have to divide it by 2 is equal to 2, right? You divide this current value by 2 and also update your min I variable with minimum of this min and current, and also push this inside of this priority queue. So we will say pq dot push this current maximum value. After we are done with this, after we will come to this position, we have to break and we have to return our deviation, that is our ans, right? So that is all that you have to do. Let's quickly run it. Okay, this is min I. Okay, so that is how you have to solve this question.